Just like we can use linear equations to model real-life situations, we can also use linear functions to do the same thing. In fact, remember that as long as we know that the equation is a function, then y can be replaced with f of x. It's just a different notation. So let's look at an example of where we are modeling a behavior using a linear function. So the total cost of owning an automobile is made up of the fixed costs, payment and insurance, and the variable costs, gas, tires, oil changes. If the fixed monthly cost of owning a 2002 BMW is $515 and the variable cost is 58 cents per mile, write a function C that represents the total monthly cost of owning a 2002 BMW. And it specifies that we need to let X represent the number of miles driven in a month. Then once we find our function, we're going to find the monthly cost if you drive 1,250 miles in a month. But let's kind of go back. So we kind of read through everything. Now let's break it down. Let's start with the total cost of owning an automobile is made up of the fixed costs and the variable costs. So let's start there. So our total cost is equal to the fixed costs plus the variable costs. In words, that's what we've got so far. The total cost, we were told to let that be function C. So I'm going to represent total cost with the function C. And we were told to let the number of miles be X. So we're going to go ahead and use the variable X in our function notation. So that simply came from, they told me the name of the function was C, and they told me to use X to represent the number of miles. So now the fixed cost for 1 month, they told me was $515 for this particular type of car. So the fixed costs are going to be $515, and then the variable cost is going to be 58 cents per mile. So 58 cents times the number of miles, and what did they tell us to use as the number of miles? X. So it's going to be 0.58x. So the total cost can be represented as the function C of x is equal to 515 plus 0.58x. Now, a couple things you can notice about this. It's not going to be necessary for us to notice this in order to answer this particular question, but I want you to see that this is very much like what we've been working with in Module 2, because what I have here is a linear equation that's been turned into a function. So remember, C of x can be replaced with y, and then I would have y equals 515 plus 0.58x. So not only can we look at this the same way, that means that we could find the slope of the line if we were to graph it, which would be 0.58, and we could also find that 515 is the y-intercept. Now, none of that really applies to the example that we're looking at here, but I just want you to see that all of this is related. It's not different pieces. It's all kind of rolled into one. All right, so now that we have our function, now we're ready to find the monthly cost if we drive 1,250 miles in a month. Well, remember that X represents the number of miles driven, so essentially what we're being asked to find is C of 1,250. So we're replacing X with 1,250, and if we do it on the left, we have to do it on the right as well. So we have 515 plus 0.58 times 1,250. So 515 plus 0.58 times 1,250, which is 725. So our total cost for 1,250 miles would be $1,240.